So on this video we are going to review over basic chemistry nomenclature. And we're going to start off with the simplest structures, the monatomic ions, and we're going to work our way all the way back up through the polyatomics. So for those of you who are struggling, this is a chance to review. And for those students who want to get a little bit ahead of the game, go ahead and watch the video and you can get a little ahead of what we're doing in our class. Now we're going to start off with monatomic ions. Monatomic ions being those that are made up of one element. And when we deal with monatomic ions, we're going to be looking at the cations and the anions. Now remember, the cations are the positively charged ions, and those are going to be indicated with a plus. So like a K plus 1 would be a positive ion or a cation. A Cl minus 1 would be a negative ion or an anion. So let's start off with our positively charged ions. Now these are going to be really simple to name. What we do is we name the element followed by the word ion. So in our first example that we're looking at, we'll see that we have K+, and so we look on the periodic table and we find out K is potassium, and so that plus indicates it's an ion. We would call this potassium ion. Likewise, the Mg plus 2, Mg is magnesium, so that would be magnesium ion, and Al plus 3 would be aluminum ion. As we move on to our anions, or our negatively charged ions, what we are going to do is something a little bit different. Now we're going to take the name of the element from the periodic table, but we're going to drop the ending and add an IDE. Now we're still going to include the word ion after the name. So for example, F negative 1, we know that F stands for fluorine. However, we're going to drop the ending, add IDE, so we have fluoride ion. S negative 2, the S is sulfur. We would drop the ending, add IDE, we would have sulfide ion. And finally, I negative 1, that would be iodine. Drop the ending, add IDE, iodide ion. So hopefully now you can name any of our cation or our anion monatomic compounds that show up. Now here we have a chart of some simple cations and anions that you're going to run across on a typical chemistry worksheet. Now the cations I'm not too worried about. I believe you won't have any difficulty with that. But let's take a moment and look at the anions. A hydrogen with a negative 1 charge is hydride. Fluorine with a negative 1 charge is fluoride. Cl negative 1 is chloride. Br negative 1 is bromide. I negative 1 is iodide. And O negative 2 oxide. S negative 2 is sulfide. So if you get a little bit confused, come back to this chart and look at the endings, and you'll see how to work with those anions. Here's a chance for you just to practice what we've gone over on the first 2 slides, and just go through and see if you can name these. The answers will be on the next slide, so just a chance to spot check what you're learning. Now if you had any difficulty with any of these names, stop by my classroom and get some help, or go back and review over those first 2 slides. But let's assume that you understand the monatomic ions, and then we're going to move on to a little bit more difficult subject. We're going to start moving with binary ions. Now with binary ions, or binary compounds, what we're looking at is a compound that's made up of 2 elements. Now a binary compound can be made up of a metal and a nonmetal, and that would be a binary ionic compound, or it could be made up of 2 nonmetals, and there we would have binary covalent compounds. What we're going to do is we will start off with binary ionic compounds. And these will be compounds that are made up of 2 elements, one being a metal, the second being a nonmetal. Now with binary ionic compounds, we were going to look at 2 types. the first thing we're going to look at is we're going to look and determine that this is indeed a binary ionic compound. Now we'll notice that we have KCl, and we look up on the periodic table. K is potassium, it's a metal. Cl is chlorine, it is a nonmetal. So because we have a metal and a nonmetal, we have a binary ionic compound. Now the way we name this is we name our first element, our metal, so we say potassium. We take our second element, which is our anion, and we're going to name that, we're going to drop the ending and add IDE. So the name of KCl would be potassium chloride. On our second example, we have MgBr2. Now we know that magnesium is a metal, bromine is a nonmetal, so we have a binary ionic compound. We name magnesium. For the bromine, we drop the ending, add IDE, the name of this compound, magnesium bromide. CaO. Now, Ca is a metal, O is a nonmetal, therefore we have a binary ionic compound. We would name it calcium oxide. Now, on our binary ionic compounds, part 2, we need to take into account those elements that have varying charges. For example, copper can have a +1 charge or a +2 charge. So we need to indicate what specific charge the element is, because the varying charges make different chemical compounds with different properties. And so with our binary ionic compounds, we also, in addition to checking to see do we have a metal and a nonmetal, we need to look at our first element in the chemical compound. Is that first element a transitional element? Is it the element tin or the element lead? If the answer is yes, then we need to include a Roman numeral in our naming. So on our first example, copper is a metal, bromine is a nonmetal. We have a binary ionic compound. Next we check copper is a transitional, therefore we will need a Roman numeral in the name. Now we know that bromine has a -1 charge from the periodic table. When we look at copper, copper must have a +1 charge because we know we have a 1-to-1 ratio. Therefore, we would have copper with a +1 charge, 1 bromide. We do not include a plus or a minus in our naming. Now, the 1 does come from the 1 charge that copper has. Let's look at a second example. We have FeS. Now we know that it's binary, and we know that it's ionic, so the next thing we need to do is, does it need a Roman numeral? Well, iron is a transitional element. Now we know that Fe is iron, and we know that S is sulfur. Drop the ending. We have sulfide, so we have an iron sulfide, but what would that Roman numeral be? Well, when we look at the periodic table, we know that sulfur has a -2 charge. We know that our iron and our sulfur has a 1-to-1 ratio. Therefore, our iron must have a +2 charge, and that will result in our having iron 2 sulfide. Now, our third example is a little bit trickier, PbO2. Now, here we have a 1-to-2 ratio, and we know Pb is lead, and we know that O is oxide, and while Pb is not a transitional, it is one of our other 2 examples, tin or lead. Now we know that oxygen has a -2 charge. If we bring that 2 down, then our lead would have to have a 4, so that our 2 and 4 would reduce to a 1-and-2 ratio. Therefore, this is lead 4 oxide. Binary covalent compounds are going to be those compounds that are made up of two elements, both being nonmetals. Now, binary covalent compounds will have a different set of rules for naming versus our binary ionic compounds. Now, our binary covalent compounds are going to be using the prefixes that are listed on this page. I have listed prefixes up through 20. Realistically, most of your examples will only go up through 10, but we will be using these on our upcoming examples. Now here we have binary covalent compounds. Now we know that each of these is binary because only two elements are present, and they're covalent because we have two nonmetals in each example. Now in our first example that we're looking at, CO2, right here, we would name carbon. We have two oxygens. Prefix for two is dioxide. Now we do not use the prefix for one when it appears on this first element. So this would not be moncarbon dioxide. However, if we did have the formula CO, we would call that carbon monoxide. So the one prefix can be used on the second element, but not the first. Again, we have one sulfur. We will not use the prefix for mon, so it's just sulfur. The prefix for 6 is hex, so we would call this sulfur hexafluoride. Now, any prefix other than one is used on the first element, so this would be dinitrogen tetraoxide. Now here you have a flowchart for naming the compounds that we're going to cover, and you can print this out at any time, or you can get a copy off of my web page or from my classroom. But this summarizes what the video and what the class notes are going over, and it puts it on this one page. So let's just take a few minutes and review over this.